It is 3:45 in the morning, so you'll have to excuse me not being 100% on the details. Probably not the best idea to do this right now, but I'm going to do it anyway. Fractions, whole numbers, adding and subtracting them, and multiplying and dividing them. I added these two new tabs, and I'm going to demonstrate a couple of problems. Going to do my best to just talk about the different methods of looking at fractions, and hopefully one of the ways that I phrase things may be helpful. So in fractions, you have your numerator at the top, you have your denominator. Those correspond to these. All right, entries over here, as you see, it's 2/3, and there we go. We also have a constant that will change. Womp womp womp. So all I have to do, clear contents on something that's already blank, and we get a new fraction. So let's go on and knock out this one. 4 minus 2/5. Let's get to it. All right, we're already good. So 4, if I knew how to type, right, that is minus 2/5. Again, you got a numerator, you have your denominator. This means that 2 is being divided into 5 parts. So if you were to visually look at this, but a better way to look at it is this. 1, 2, 3, 4, 5. So if you want to look at this as 1/5 over 2/5, I know somebody would be like, well, nope, that's just boxes or whatever instead of numbers. So that's a way of looking at it. If you want to look at 2 complete, I would have to like copy these, and if you were to try to divide this equally, well, kind of can't, but let's just say you could. Oh, that's because I'm not supposed to count that one. Yeah, sorry. So it would be 1, 2, 3, 4, 5. Sorry. Like I said, it's 4 o'clock in the morning. You'll have to excuse me. So again, this is where those improper fractions, if you would, come in. All right, because again, you're just looking at this. This is evenly divided. All right, so you have 1/5, you have another 1/5, you put them together, you have 2/5. If you look at it this way, we started out, I will use a highlighter on this, and we'll give it this. So again, we started out like that. And what I said, because these have to be equally divided, then we had to switch things up. Oh God, there's an AKA joke in here. Notice I did that 5 times. All right, so again, 5, all right, divided technically, or 2 that have now been divided into 5 equal parts. Hopefully that made sense. Let's say that 1/5 is this. It got a little bit bigger. So again, if you want to divide this equally into 2 parts, and you would say, well, let me do that right. We need to stop here, and then you'd have the other one. So again, notice we have 5 that is divided into 2 parts. or 2. I hope that made sense. I know I said that. What I said, 5. Yeah. 5 by 2, 2 by 5. Hopefully that makes sense. So again, just did it backwards. I did 1/5 over here. If you want to be super technical about it and be like, well, hey, it's only 1/5, then we can just simply double. Alright, and again. Okay, so hopefully everybody is happy now. I'll use the same way of doing it. That way nobody's like, you totally switched it up. Alright, so 1 set of 5, another 1 set of 5, and then we divided that into 2 for it to represent 2 over 5. Okay, I hope that made sense. I kind of don't want to do more, but nonetheless, if something, so we're talking about 2 sets of bit. Okay, 2 sets of bits. You can look at this as it's doggy shaking. Okay, so we had 2 divided into 5 equal sections, which is how we got this. I will outline this in black, so this is again super clear. I'll use the large one. Okay, 2 squares broken up into 1 set of fifths and another set of fifths. Hopefully that makes sense. We do have, again, it has to go across lines for it to be equal parts. Literally, you can see the brokenness or the fraction or the fracture that's happening. Hopefully, again, that makes sense. We need to rewrite 4 as a fraction, particularly something that is over 5. Alright, so we're looking at the least common multiple between 4 and 5. Alright, 1, 4, 8, 12, 16, 20, 1, 5, 10, 15, 20. We had to do it 4 hops. So this is 1, this is 2, this is 3, this is 4. Over here we had to do 5. So 1, 2, 3, 4, 5. So notice these match. So notice the synchronicity. It's not gonna be perfect, but I think you get the picture. So we've got 20. Alright, 20 divided by 5 is going to give us 4. 20 divided by 4 is going to give us 5. So that's the commonality. It's the common and the least, the smallest. As soon as we got there, All right, want to be as efficient as possible. 20 divided by 5, because 5 needs to be in the denominator because it needs to match up. Okie. So again, 20 divided by 5 gives us 4. All right. We just talked about that. We could do it. Because this is 2 sets of 5, these blue blocks, 1, 2, 3, 4, 5, and I'll even write those in there. 1, 2, 3. Notice how I wrote that. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's 10. If you were to double this, then you would be able to see 20 divided into 5. And again, you would have 4 sets of those 5, because you would have the first 5, the second 5, the third 5, and the 5th. All right, or if you want to just count these little suckers right up here. Because the denominators are the same, you can combine them when it comes to addition and subtraction. And 20 minus 2. If we take flump and 5 away, 1 from here, 1 from here, we'd have 4 plus 4, which is going to give us 8, plus the 10 from down here. That's our 18 over 5. That's one answer. And then I said, please do it also as a mixed number. So 5 would go into, if you were to rotate clockwise, we'll end up with 5 divided by 18 goes into it 3 times. 15. 3 left over. And that's 3 that goes up here, and 5 that stays as the denominator. 3/3. If you want, we can then take a moment. You know what? I'm going to be an overachiever. 18 over 5, 3 3/5. 18 over 5. Gonna do this as a decimal, 3 3/5. Okay, so again, rotate. If I can't go into 3, but you can do this. So remember, you also have the 3 that's still there. And because this is a decimal, this is a fraction or a decimal or a piece or a smaller bit added onto the whole number. So if you don't believe that, let's look at 18 divided by 5. 3.6. Just put that here, 3.6. So again, 3 divided by 5, 0.6 plus the 3. 3.6. I think we're good. Let's go on to the next one. So again, just to recap, we started off with 4 minus 2/5. Wanted to look at the 2/5 and talk about the fact that we've got our numerator, we've got our denominator. I drew 1/5 and another 1/5 because we had 1 represented here with blocks or whatnot, and 5 being the denominator. So in other words, we were trying to divide this 1 into 5 equal parts. And so kind of demonstrated that starting down here. I did 1/5, so I made a 1 or one single shape divided equally into 5 parts, and then I doubled that, or I did another same size, arguably. I am not an artist like that. one solid shape divided into 5 equal parts. That gave us 2/5. I represented that with the black box says, and it did have to split this in the middle. Yeah. And you could even look at that if you want to look at 5 divided by 2. You can't, but you can say that's 2.0 and then make that 20, and that would be 0.4. 4 minus 2/5. So we have to get 4 into a fraction, because the only way you can put fractions together when you add and subtract is when they have the same denominator. So in order for us to get 4 to the same denominator as a fraction as 5, then we have to find the least common multiple. So we go through our times tables. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. So again, we're thinking about hopping. Or if you were to look at this as, again, this, you would have a set of 4, another set of 4, another set of 4, another set of 4, another set of 4, if you were to add them all together, because that's all multiplication is. Same thing with here, 5 times 1, 5 times 2, 5 times 3, 5 times 4. And, or again, you can think about it this way. 5 plus 5 is going to be 10, because you have 2 5s. If you want to start from scratch or nothing, you would take 0 plus 5. That is 0 plus 1, number 5. 0 plus 2, number 5s is 5 plus 5. All right, just going into that little simple part. All right, finishing on up, 20 is what we get, because 5 times, oh, that's missing. That was here. Don't know why it went away. Just linking it and showing. So again, 5 times 4 is 20. 4 times 5 is 20. We need it to be 5 at the bottom. So 20 divided by 5 is 4. That would get us right back to where we started. Because the denominators are the same, we can now combine these. 20 minus 2 on the top gives us 18 over 5, or 18/5. 5 goes into 18 3 times with 3 left over. This 3 that's here goes into the numerator of the remainder. And this stays as the divisor. Please forgive my handwriting. Like I said, it is, as you can see, 410. 409. But again, 3 3/5. What I then decided to do was to talk about that in terms of a decimal, just as a means of checking. So we already went over this, and that 5 goes into 18 3 times with 3 left over, and that gets us here. So that 3 can be looked at as a separate, because this is 3 and or plus an additional 3/5. So and is going to let you know that you have a decimal coming. Means you also have a decimal coming. So again, 3.0, because 5 cannot go into 3, but it can go into quote unquote 30. So you look at that as 30, keeping the decimal points lined up, and you get 0.6. We looked at that over here, and we did get 3.6. So we wrote our answer now 3 different ways. We have it as a decimal, we have it as a mixed number, and we have it as an improper fraction. Alrighty, let's go on and look at the next one. Yeah, why not? 5 divided by 1/4. Alright, we've got 5 divided by 1/4. Okay, so again, you want to divide 5 equally into fourths. So if you want to start off with getting fourths, and then looking at how many fourths make up a whole, And then you look at how many whole numbers or holes, ones if you will, are in 5. Then you're going to have 5. So then you're going to have 5 sets of 1/4. So that's going to be 20 of them. But that's just a verbal walkthrough. So let's actually make that into something that is tangible. So again, if you have one shape that is divided into 4 equal parts, that's pretty decent. I mean, it's not perfect. We've got 1, we've got 2, we've got 3, we've got 4, we've got 5. Why I did 6, God only knows, but let's just go on and pretend that we did not. Right, 1, 2, 3, 4, 5. So, as I said, again, if you want to look at this as the hops, or if you want to look at this as the total number, we've got 1, 2, 3, 4, 5, 6, 7, and I'll even write these to represent the 5. Alright, so again, 5 divided into 1/4 is 20, but there's one way of looking at it. Let's go about this the written route. Alright, so what you really have is 5 divided by 1/4. So you can look at this as 5 over 1, bigger fraction bar. 1 over 4, flip denominator, switch operation. So 5 over 1, instead of the dividing or fraction bar, we now have multiplication, and then instead of 1 over 4, we flip and it's 4 over 1. Because this is multiplication, we go straight across the top and straight across the bottom. So we end up with 20 over 1, which is simply 20. Okay. I'll leave that be for right now, because this has been a little 20-minute ditty. So, God's blessings, good things. Hope this was helpful. And best of luck, kiddos.